Happy Monday, mathematicians! So we are on lesson 20 of module 5. So let's get started, and our first thing is actually a review activity with our dot cards. So these are all different 7 dot cards, okay? So I'm telling you the total because what I really want us to see is different parts. We're reviewing the parts today. So here's the first one. What's the total number of dots? So first, right away, double check that what the total number is. So 1, 2, 3, 4, 5, 6, 7. Awesome. Now you figure out what 2 parts you see here. How do you see 2 parts in this picture? And then we're going to say it in a number sentence. So I see 5 and 2 make 7. Or there's lots of other options, right? Maybe you see 4 and 3 makes 7. Both great answers. Let's try another one. Okay, what is the total number of dots you see in this picture? Awesome, 7, same thing. Now let's figure out how do you see the 2 parts. What do you see here? I see 4 and 3 makes 7. That's the one that's very clear to me. Maybe you see something different. Say yours in a number sentence now. Awesome. Let's do a different card and see if we find something different. Okay. We could turn this one different ways, right? It doesn't change the value, but maybe it changes how you see things. So, yet again, let's start with our first question. How many dots do you see? Okay, awesome, you got it, 7. Now, how do you see the 2 parts to make 7? Now this one's might not be as clear as the first 2. Maybe it's a little bit different. Maybe you see 3 and 4 make 7. Or maybe you see 6 on the outside and 1 in the middle makes 7. So 6 and 1 makes 7. Did you see either of those? Or maybe you saw something different? So far we've done 5 and 2 make 7, 3 and 4 make 7, 6 and 1 make 7. Oh, okay, so how many do you see here? 7. Now, how do you see 2 parts? So this one to me is definitely 6 and 1 makes 7. 6 and 1 makes 7. Or 1 and 6 make 7, right? I can always flip-flop how I say it. Okay, and then let's do this one. Okay, how many do you see here? Awesome, and now how do you see 2 parts? And then let's say that in a number sentence. So I see 5 and 2 make 7. Or 2 and 5 make 7. I just reversed the number order. Okay, and then let's do this one as our last one. How many dots do you see? 7. And what are your parts? Who sees 6 and 1 makes 7? Or 1 and 6 makes 7? Awesome. And just for fun, since we didn't do this part, what about 7 all together and 0 makes 7, right? If we made it one big group, 7 and 0 makes 7. Okay, awesome job, guys. So the next thing we're going to do is on Friday in morning meeting, I reviewed the Reckon Ricks and what they're useful for and how they're a great math tool. So we're going to practice counting on the Reckon Rick. I'm going to get our big Reckon Rick and we're going to count all the way across every bead. And in the last spot, instead of saying the number, we're going to say buzz. Okay, so let me grab the Reckon Rick. If you have one of your Reckon Rick papers from last week's activities, problem sets, you could grab that now and then you could use that to count along with us, or you could just watch along with Miss Tracy counting on here. So remember, we're gonna say buzz for the last bead in each row, which is our last number in each row, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, buzz! 11, 12, 13, 14, 15, 16, 17, 18, 19, buzz! 21, 22, 23, 24, 25, 26, 27, 28, 29, buzz! 31, 32, 33, 34, 35, 36, 37, 38, 39, buzz! 41, 42, 43, 44, 45, 46, 47, 48, 49, buzz! 51, 52, 53, 54, 55, 56, 57, 58, 59, buzz! 61, 62, 63, 64, 65, 66, 67, 68, 69, buzz! 71, 72, 73, 74, 75, 76, 77, 78, 79, buzz! 81, 82, 83, 84, 85, 86, 87, 88, 89, buzz! 91, 92, 93, 94, 95, 96, 97, 98, 99. Last one, buzz! So, remember, when we were doing buzz, we are skipping that number, which is our 10 number, right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Awesome. Okay, guys. So now I made 4 different configurations. Some of them are circular configurations and some of them are arrays, just so we can practice counting them. So let's start with an array first. So here's an array of hearts. So let's think of different ways we can figure out the best way to count them. Now, counting in groups of 10 we know is going to be the fastest, and these you can see are 1, 2, 3, 4, 5. So these are made in the 5 group way for you. So this is 5 and 5, that's a group of 10. 5 and 5, here's another group of 10. 5 and 5, another group of 10. 5 and 5, another group of 10, and then we have some ones. So an easy way to do this, if you're able to draw on it, even better. If not, you have to do it in your brain, is let's count our groups of 10. So if we had a group here, a group here, a group here, and a group here. We have 1, 2, 3, 4 groups of 10s. 4 10s. What's 4 10s make? 40. So then we have 10, 20, 30, 40, and 2 1s. So what's 40 and 2 make? 4 10s and 2 1s is 42. So we worked on building those numbers last time. Remember, we would have the 40, the 4, let's see if I can find it. If we had our 40 card, like that, that represents these 4 groups of 10. And then what would we put over it? We would put a 2 to represent the 2 1s. I'm not sure I have a 2 handy, but if we had 2, we would put the 2, oh, here it is. The 2 represents those 2 leftover ones, and then we'd put it on top of the 0, and we'd make 42. Okay, awesome. Let's look at our next one. So I'll do our next array. Whoa, you probably looked at this and were like, oh my gosh, that's so many lines. How will I ever be able to figure this out quickly? Well, you can, because I think they're in groups, rows of 10 already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, they are already organized in rows of 10, and we know that rows of 10 is an efficient way of counting. So let's count how many rows. 1, 2, 3, 4, 5, 6, 7 rows. So that's 7 tens. Now, you're probably like, Miss Tracy, you didn't add the last row. But this one I can tell is not a full row of 10, right? It's shorter. This only has 1, 2, 3, 4, 5, 6, 7, 8. So we have all these rows of 10 and then 8 ones. So 1, 2, 3, 4, 5, 6, 7. 7 tens and 8 ones. Who knows what 7 tens and 8 ones is? So 7 tens, if you're not sure, 10, 20, 30, 40, 50, 60, 70. 7 tens would look like this. 70. But we have these ones, right? These ones on the bottom row. 1, 2, 3, 4, 5, 6, 7, 8. So we need to find an 8 to represent the ones. Here's our 8 for our ones. So we have 70 up here and 8 ones. 7 tens and 8 ones is 78 dots are on that page. A fast way of counting. 10, 20, 30, 40, 50, 60, 70, 71, 72, 73, 74, 75, 76, 77, 78. 7 tens and 8 ones. Awesome. Now, those were in arrays, which means lines, organized maybe horizontal or vertical, very organized. And I have 2 circular configurations. Now, we know circular configurations are trickiest because it's easy to lose your place when you're counting. So when it's paper, an easy tool is you could check it off as you're counting or maybe identify your starting point. So let's work on these 2 now. And we'll start with the asterisks first. So I'm going to start a circle to identify my group of 10. So here's my starting circle. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this kind of C-looking shape, there's 10 asterisks, backwardsy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I can figure out I have 1 10 and how many ones are left over. 1, 2, 3, 4, 5, 6. So I have 10 ones and 1 10 and 6 ones. 1 10, 1 10, right? 1 10 and 6 ones. 1 10 and 6 ones, hide the 0. What do we have? We have 16 in this circular configuration. Okay, let's do our last one really quick and then move on. So it's another circular configuration. This one looks like it might have more than 10. It looks like a bigger circle. But let's use the same way to figure it out. So I'll start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is a circle of 10. Do you think there's enough to make another circle of 10? It looks like it to me, so let's try it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So I have 2 10s. 2 10s in this one. And how many 1s are up here? 1, 2. So I have 2 10s and 2 1s. That makes 22. So there's 22 squares in that circular configuration. So as you can see from my different examples, a good way to do it is, if it's a harder shape, maybe do identifying marks to keep your place. You could count them out. You could just count in 10s, all different ways to do this. Okay, now it's time for our word problem. So let me clear the board so we can get set up for our word problem. Okay, so grab your pencil and pen or writing utensil. If you haven't been writing along yet, it's a great idea to do your word problem with us. So today's word problem is, each student was given 6 colored pencils and 4 regular pencils. So 6 colored and 4 regular. I didn't tell you the total. I told you the parts. So just like when we were working on our dots, figuring out the parts, now I'm telling you the parts. We don't know the total. So draw a picture and a number bond and write a number sentence. So you need to do 3 things. You need to do your word problem picture, you need to do a number bond, and you need to write a number sentence. So again, I'll say it one more time. Each student was given 6 colored pencils and 4 regular pencils. How many pencils did each student get? That's the mystery number. How many pencils together, colored and regular? What's the total number of pencils? Draw a picture and a number bond and then write a number sentence. So I'm going to use 2 different colors because I have that handy. If not, think of another way you can identify which ones are colored and which ones are regular. Color starts with C, so maybe label it C. Regular starts with R, so maybe label it R. Okay, so I'm going to start with my 6 colored pencils. So that's, 2, 3, 4, 5, 6. So that's my 6 colored, and I'll write C above it for colored. And then I'm going to draw a line dividing my pencils. So another way to show division. 6 colored pencils. Now I'll use red for my regular pencils, and there's 4 regular. 1, 2, 3, 4. And there's an R for regular. So now I have all of my parts drawn out, and now it's time for my number bond. Actually, let's label. There's 6 here, right? 6 colored and 4 regular. So I just identified it now. 1, 2, 3, 4, 5, 6 colored, 1, 2, 3, 4 regular. Now I'm going to do my number bond. So I don't know my total yet. So I'm going to fill in my parts first. 6 colored, 4 regular. Now, a lot of you might be like, Miss Tracy, I already know 6 and 4 makes beep. But if you don't know what 6 and 4 makes, 6 plus 4 equals, what can you do? Count it, of course. 6, starting with our bigger number, 6, 7, 8, 9, 10. Yes, and if you said, Miss Tracy, 6 and 4 makes 10, thumbs up, that's right. So our total is 10. Now, we drew out our story, we made our number bonds, but now it's time for our math sentence, our number sentence. So 6 plus, remember this is an adding problem, 4 equals 10. Now there's multiple ways we can write this equation, right? We could flip-flop the numbers, though we've been talking about always starting with the bigger number, right? That's why I did it with 6. But you could write 4 plus 6 equals 10. We just reversed it. Or we could put the total in the front now that we know the total. We could do 10 equals 6 plus 4, because 10 equals the parts of 6 and 4. Or we could flip-flop that again, 10 equals 4 plus 6. So all different ways. These are all correct number sentences, and they're all sharing the same information. Okay? Awesome. So we are going to quickly move on to our next activity. Let me erase our word problem. And I'm going to draw a number bond. So if you have a number bond handy, that'd be great. If not, you could just draw one. So I'm going to draw a freeform number bond. Trying to draw it a little bit bigger so you guys can really see it. Now, I'm putting some of our magnet chips in there. I'm going to do the parts, just like in our word problem story I told you the parts. 6 colored pencils and 4 regular pencils. So there's going to be 10 red chips. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 red chips. Now my other part is 3 yellow chips. 1, 2, 3. Okay, what is 10 ones and 3 ones? What is 10 ones and 3 ones? What's it together? 13 ones, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 ones. How do we say that in the say 10 way? 10, 3. 10, 3. Now, I'm going to move them all to the whole so you can really see that happening. So here's 10. Ten, 3, all together is now in the total, and that makes 13. So the two parts were, we had 10 here, we had 3 here. I moved them all up there to the whole 13. Now, we've used all different ways to figure this out. We have our 10 red, and then our 3 yellow, 10, 3, right? Let's match it up with the parts. 10, 3, put it together, 13. Now, just like for our word problem story that we just did, like these dots are kind of like how we drew the colored pencils. We just didn't draw in this one, I used little chips. So just like with our word problem, first we drew it, so I used the chips. Then we did our number bond, which we did all together in this problem. Next, we need to write our number sentence. So let's start. 10 plus 3 equals 13. So we had 10 plus 3 equals 13, right? 10 and 3 make 13. Now, I'm really trying to emphasize the importance of starting with the group of 10, not 3. Because if you weren't sure, it's much faster to go skip 10, 11, 12, 13. That's the fastest way. So we're going to keep our math equation at 10 plus 3 equals 13. However, let's flip-flop it. Remember, the 13 was our mystery number, right? 10 and 3, what did that make? Oh, 13. Now let's flip the number sentence. 13 equals. Now what's 13 equal? If we had just given you 13, how did it break into the two parts? Oh, 10 plus 3. Make sense? Let's try that one more time with a different number, and then let's do our problem set. So I'm going to quickly erase this. I'm going to move these dots to the side because I'll use them for the next problem. Draw a new number bond. I'm going to change up the configuration this time just as a reminder that it can go all different ways. Okay, and I'm not going to tell you the whole. I'm going to just tell you the number of chips. So this time I'm going to start with 10 yellow chips. 6, 7, 8, 9, 10. I made my number bond a little small this time. So I have 10 yellow, and this time I'm going to do 7 red. 1, 2, 3, 4, 5, 6, 7. Okay, awesome. So, what are the parts? 10 yellow, 7 red. Okay, let's say it, how many ones is that all together? Let's figure it out. So 10, 11, 12, 13, 14, 15, 16, 17 ones. So we have 17 ones on the board, some yellow, some red. What's the say 10 way of 17 ones? 10, 7. If we wanted to write it, it would say 10 for the yellow and 7 for the red. 10, 7. Now, we got to fill our hole. So we scooch these up the number path, right? My number path is getting erased as we do it, but you guys know what's happening here. And just as a reminder, we had 10 yellow up here, 7 red down there. Now they're all in the whole circle together. Let's do our high 10 card. So here's our 10 yellow. Now I need to find our 7 for the red. 7 ones. 10, 7. Hide the 0, and we have 17. We can write our math problems. Oops. 10 plus 7 equals 17. 17 equals 10 plus 7. Okay, that is a lot so far. It was a big lesson actually today. So I want to get to our problem set now and just quickly show you how to do a few of the problems. Okay, so it's a number bond page. I don't think we need to review this too much because we've been working on number bonds for almost half the year now. So fill in each number bond and write a number sentence to match. Same thing we did here. We made a number bond and then made the math sentence. The last two things I did, and even the word problem with the colored pencils and regular pencils, set you up perfectly for this. So you can see the first one's done for you, the example. 13, 10, 3 are the parts. 13 equals 10 plus 3. All of these I can tell you with a quick look will have one part is 10. And they give you a mix. So like this one tells you the whole is 15. And you need to fill in the part 10, 5, and then 15 equals 10 plus 5. But here it gives you the parts. 10, 7, the whole is 17. That's exactly the one we did on the board last. And then 17 equals 10 plus 7. Now there's the parts here, missing the whole. Only one part, and then missing the other part in the whole. This one you need to fill in completely. And make sure we look at our number sentences, our equations. Sometimes it's asking you for the total, and sometimes it's asking you for the parts. Remember, look for your symbols. The plus sign is adding things together, and the equal is the total. And then there's 2 more down here. Okay, and then the next page is just to circle the parts. So the total is 12. What of these numbers makes 12? So there's an example here. The whole is 5. Which of these numbers makes 5? And you circle it. So 12, does 10 and 6 makes 12? No. 10 and 6 makes 16. Does 10 and 2 make 12? Yes. So you would circle 10 and 2. Okay, the next one, 11. So there's 3 numbers here, 8, 10, and 1. Which 2 numbers make 11? 10 and 1. Awesome. And now you can do the rest on your own. The whole is 14, 18, 10, and 20. And then there's a couple more pages where you're just drawing in the parts. So the total is 11. So you did 10 stars and 1 star. The number is 15. You do 10 stars, and then how many more are missing? 10 and 5. Yes, so you would draw 5 stars. And then in this space, you can write the math sentence just like they did here. So 10 plus 5 equals 15. 15 equals 10 plus 5. Now take your time on this. There's 2 problems you need to write. You need to fill in your missing stars. Here's 17. Well, it looks like this is 5, 6, 7. So we have the part of 7. What's the other part that's missing? 7 and what makes 17? Well, 7 and what makes 17? 10, exactly. So you would draw 10 stars. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then do your math sentences just like I did here underneath. And then there's a couple more, just the same thing on here for 19, 14, and 20. Okay, guys, that was a big math lesson today with lots of information. So take your time on your problem set worksheets and let me know if you have any questions at all. Okay, bye.